Alright, so we're going to try to make this pretty quick. There's only a couple slides here. We're going to talk about a few forces that we experience every day. These forces are actually a big deal of why different things happen to us on an everyday basis. And let me try to do it again. Alright, so we're going to try to get this done real quick. We're going to talk about everyday forces. Now, what I mean by everyday forces are these are forces that we experience every day. They affect our lives pretty significantly every single day. There's only two slides here, so let's try to make this real quick. So the first force is gravity. So gravity is an attractive force between any two objects. And when I say any two objects, I literally do mean any two objects. So technically speaking, my cell phone and me, there's a force of gravity between us. There's obviously the force of gravity between us and the Earth. There's a force of gravity between my PS4 controller and my markers over here. Now, here's the thing. You don't see my cell phone going to me because of that force of gravity. The truth is, even though all objects technically have a force of gravity on them, between them, a lot of these forces of gravity are insanely weak. Like, they're so weak that they wouldn't actually move these objects in any reasonable scenario. Now, things like planet Earth, the sun, other planets in the solar system, even our moon, all have gravitational forces that pull objects towards them. This is because these things have so much mass. They are so big that they are able to exert a strong force. So, cool thing is, the more mass an object has, the stronger the gravity it has. So, a way that you can look at this is think like the moon, Earth, and Jupiter. The moon is the smallest of these three objects. It by far has the weakest gravity. Gravities have different numbers that scientists have figured out. It's how much acceleration the gravity puts on objects. I'm not going to stress you guys out about that too much, but different gravities have different forces that they put on objects. The moon's gravity, if I remember its number correctly, it's like a 1.4. Earth's gravity is 9.8. Earth's bigger than the moon. It should have a bigger number. It should have stronger gravity. If I am remembering correctly, I think Jupiter's is something like 36 or something ridiculous like that. It's really interesting to think about because Jupiter's bigger, but it being bigger isn't technically what is making its gravity stronger. It's the fact that it has more mass that makes its gravity stronger. Greater mass just is the main point here. So that's our one force, gravity. It's always pulling us down. It's always pulling us down to Earth. If Earth's gravity was weaker, we probably wouldn't be pulled down as much. Like, we'd still stand on Earth, but it's like when you jump, you fall straight back down to the Earth. If our gravity on Earth was weaker, when we jump, we would fall down slower. And then the other slide is friction. So here's what friction is. Friction is a force that applies when two objects are pressed against each other. Here I do say rub against one another, but that's actually not technically true. It's when two things are pressed against each other. We have different types of friction that occur. So here's what I want you to do real quick. Take your hands and put them together, and then just start rubbing them. While you do this, you should feel your hands start to heat up a little bit from at all the places where your hands are rubbing against one another. This is because of the friction force. So what friction does is it's the force that occurs when two objects are pressed against each other. If I were to take something like, for example, my phone, I have my phone right here. I place it on my desk, and I just slowly push it. You notice that when I push it, it doesn't keep going. Even though we mentioned in Newton's first law of motion, an object in motion will stay in motion until affected by an outside force. Technically speaking, by this mindset, when I push this phone, it should just keep on going straight across my table. Like, I shouldn't need to do anything else. I should be able to go boop, and it'll just keep on going. Well, it doesn't. And the reason it doesn't is because of this frictional force. The contact of the phone against the table applies friction. So, when I push it, I can push it enough that it'll slide a little bit, but eventually this frictional force is going to take the motion of my phone and is going to bring it down to zero. This happens with anything. Like, this is why cars will roll to a stop. This is why, like, different things just will stop over time when we slide them or when we push them or when we roll them. An interesting thing about frictional force, like, this is super important. And here's why. If you've ever walked on ice and you've gone a step and you couldn't move, you couldn't push yourself forward, you're just slipping and sliding all over the place. This is because on ice, there is very little to no frictional force. Like, it's not quite zero, but it gets extremely low. And when we walk, we actually need this frictional force to push ourselves forward. Like, our foot, at the point of contact with the ground, that friction, our foot is pushing off using it, and that's what's moving us forward. If that friction is suddenly gone, our foot pushes and it doesn't go anywhere. It's like we push and then our foot just slides around. This is why you fall when you start slipping and sliding on ice. It's you go to step and whoop, you're gone. It's really interesting to think about, truthfully. Alright, that's actually all I wanted to talk about. These are forces that we experience every day. They're things that are honestly extremely common in this world, and a lot of things are based around this. Like, even our planes flying has something to do with this gravitational force, because our planes flying need to overcome that gravitational force going upwards as to, be able to fly through the air and take us places. Alright, that being said, I'm done. Couple quick questions. Not going to be too many today. Everybody have a good day. Good night. Stay safe.